Another problem that I've seen often on problems like this with optimization has to do with farmers and cows. So let's say that we have a farmer wants to build a fence for his cows. And he wants to get the maximum area out of it he can afford. Let's say 1,000 feet of fencing. So he can afford that much fencing, but he wants to get the most bang for his buck. He wants to get the biggest area possible so he can fit the most cows into that space, or that the cows would have more room to roam, whichever one he prefers. And let's say that he's going to build along a river. So here's his river, and he is going to somehow build a fence that is going to have some length and some width to it. But conveniently, one of the sides for the width he doesn't have to account for, because the river, the cows are not going to go swimming. The river is going to be the natural boundary point on the one side of this fence. So in this case, what we're being asked to maximize is we're being asked to maximize the area. Remember, so the cows have more room to roam, or so he can fit more cows into the pen, whichever one he prefers. We want to maximize the area. What that means is we want to have an area equation in terms of, again, I'm going to use X on all of these, just to get you used to that idea of switching your variables and not using your L's and your W's. It's not the worst thing in the world if you use them, but you can't use both. And I think it's just easier to switch both things to X. So what we do know is more an idea of perimeter, not necessarily area, right? Because we know how much fencing he has. So it's not exactly perimeter, because we are going to ignore the side with the river. But I know, first of all, I know that my area is length times width. I also know that if I take length plus width plus length, it's going to equal that 1,000 feet of fencing that the farmer has. And of course, I can simplify this even a little bit for myself. And let's use this to solve for a variable. Let's go for the easiest variable. Let's subtract this 2L over. W equals 1,000 minus 2L. This means that now I can rewrite my area equation in terms of, I can replace the W with things that have a different letter. So I've got L times 1,000 minus 2L. Now you do have two options here. If you wanted, you could take the derivative with respect to L. I'm going to switch things to X again, just when you have multiple things, I think it's be easier. Let's go ahead and say that X is going to be the same thing as L, which means that W will be the same thing as 1,000 minus 2X, so that I have my equation in terms of X's. And I could use the product rule on this, but it's one of those situations that the algebra is so easy right here. Why not go ahead and take care of the algebra and then come back and do the calculus on the easier algebraic problem? So I am going to go ahead and distribute this X into my problem. So I get 1,000 X minus 2X squared. Now I know I want to maximize the area. Again, want to maximize your area. So we're going to take the derivative of the area equation and set that derivative equal to 0. Again, this is a sort of problem with the numbers that you would definitely see on a non-calculator portion of the test, because this is much, much easier number-wise. So, in fact, all I need to do here, I've got 1,000 minus 4x equals 0. let's add the 4x over. 1,000 equals 4x, divide by 4, divide by 4, and we get x equals 250. And so therefore, the length of the fence would be 250 feet. The width, remember the width, we had that equation up here, 1,000 minus 2x. It would be 1,000 minus 2 times x, which was 250. In other words, 1,000 minus 500. In other words, 500 feet. So I would get a maximum area if I have 250 feet of fence here, 500 feet here, and 250 feet here. And then the farmer and the cows are all going to be just as happy as can be.